Well, let's take a look at topic 29 here today. Describing and analyzing data. So in statistics, there's a lot more into it, but these are some of the most fundamental things that we probably encounter. All right. The word mean is referring to as the word average. We always says the average. Mr. Chan, what's my average in the class? What's my average? All right. uh, your average is not just simply add them all up divided by how many assignment you did. It's actually called the way how grades is being the way how the grades is being calculated is actually called the weighted mean. All right, because every assignment has a different weight. That's why it's called a weighted mean. I'll show you that. Show you kind of something similar to it in a minute. All right. The word mean is what we normally prefer as average, but the word average itself, when when people just say the word average, AVE, oh Lord, the word average itself actually can refer into mean, median, or it can refer into as mode. It's actually all three things. Okay. So whenever you say, okay, add them all up, divided by so many you added, that's actually called mean in statistics. All right. Median, some of y'all may remember this, is the value that lies in the middle of the data when we actually arrange the entire data in the ascending order from the smallest to the largest. Okay, so the one in the middle is called the median. All right, the mode is referring to data that occurs the most. Why? Okay, why does the word median got to do with central tendency? Central tendency means what lies in the middle. Okay, what's the average? What's the mean? You know what I'm saying? What lies in the middle? Imagine there's like 10 of us in a class, all right, rather than just 5. If there are 10 students in the class, okay, and there are half of them making 95s. You know what I'm saying? And a couple of them make 80s, right? One, and then 60s. By looking at this, where do you think the class average is going to be? Is it more tend to be 90s or 80s or below 80s? The mode is referring to the data that occur the most. Okay, so if 95 occur the most, that actually that actually shifting your center towards the higher grade. Okay, so your center of your entire distribution, actually, that's how we actually say it, actually leaning more towards the higher grade than lower grade. All right. So have you ever heard, before, like, people curve? I don't know, maybe that's something old. Like I have been in a class where only one student out of 30 students making 90s. One make 90s. And everybody else, the other 29 making 60s and below. So what did the professor end up doing? Professor ended up had to curve, right? You know what I'm saying? But that's kind of strange because your whole entire display of grades is actually on the lower end. Okay, so you're basically, so when you curve it, make everybody grades higher, it's a little bit strange. It's not statistically sound. So that's why, that's the reason why, I don't really do curve, because it's not, it has no, it really have no mathematical, you know, statistical thing into it. Okay, it would just basically say, okay, everybody making 60s now B. So it's got to be mathematically sound. Got to be mathematical, makes sense. All right. So mode does affect what lies in the middle. Central tendency is shifted. All right. So let's go ahead and do this. I think I'm using these numbers again. in a little bit. So I would like us to kind of figure this out. All right, find the mean. Mean is just like the word average. We add them all up and divide it by so many we added. So just make sure you don't type in it wrong, okay? We're gonna add them all up first. So I'm gonna put in my calculator, 46 plus 47 plus 47 plus 48 plus 42 plus 42 plus 45 plus 41 plus 35 plus 52 plus 39. All right, add them all up. Oh, do y'all mind if I write this down? Okay. I'm gonna purposely write this, okay? All right. Individual data is called XI. Sum of the XI, that means add up all your, this is a summation sign, add up all your data and then divide it by so many you entered it. So right now my sum is 454. All right, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my mean, which is actually called X bar. Okay, that's a notation for mean. X bar divided by 4 is 113.4, oh, not 4, cut 11. 454 divided by 11. All right, 41.27, something like that. Okay. All right, number 2, find the median. To find median, I gotta write this from small to the largest. Okay, you might have to help me. Smallest number I got is 35. No, yeah, 35, 39, 40, 41, 41, 42 twice, 43, 44, 45, 46 one time, 47 twice, and a 48. Ugh, darn it. Oh, make it too big. All right, let me just squeeze it in here over here. All right. So we actually learned to find median for another type of display of data. Okay. Some of y'all might heard something called the box whisker plot. All right. So normally to actually find the median, we just take the ends off. Okay. Take the ends off. Work your way to the center. All right. So hold on a minute. What? Did I do this right? 52. Man, I forgot 52. Okay, 52. Let me go back. All right, I left out 52, sorry. Okay, take the ends off, right? Take the ends off. Work your way to the middle. So because I have odd number of data, then whatever the number is left in the middle, that'll be my median. If I have an even number of data, then the last two number left in the middle, what you do is add them up, divided by 2 to find the true center of the entire data set. Okay. Number 3, find the mode. The mode is the number occurred the most. Well, both 42 and 47 occurred 2 times, so both of them are my mode. If every number only occur once, then there's no mode in the problem. All right, so I think I will use these numbers here in a minute, but let me show you this weighted mean. Okay. So I'm not necessarily teaching you how to calculate your grades per se, because there's a lot of things you did for the class, but the way how your grades being computed is something called weighted mean. Okay, weights, not every when not every item weighted the same, then the way how we add them up, okay, is actually considered as a weighted mean. A little bit multiplication here involved. So pretend we got these 4 classes, okay? Some of y'all's technical classes has a weird credit hours, okay? But how you compute it is the same. So generally English, math, and psychology are 3 hours each. Biology is a lab course. It has a lab component to it, so it's actually 4 hours. Some of y'all technical shop classes actually has more credit hours, okay? So, but for example, if you take an English class, which is 3 credit hours, and you made a B, okay? So what that means is a B is a 3.0. For a 3 credit hour class, that means you make 3.0 3 times. Okay, you make a B, you actually make a B every hour. So that means you make 3 Bs. All right, I hope that makes sense. If you make a C in the biology class is actually a C is 2.0. Since biology class are 4 credit hours, that means you actually make C 4 different C's per hour. You actually make a C per hour. That's 2, 2, 2. Okay, so we're gonna add them all up. So rather than add up 3 plus 3 plus 3, what we can do is take the credit hour 3 times the GPA. That will give you the sum of your the sum of your points. I call them points. If you made an A in math, A is 4.0, 3 credit hour class. So that means you make 4.0 for 1 hour, 4.0 for another hour, and 4.0 for the third hours. So if you add them up, 4 plus 4 plus 4 will be the same thing as 3 times 4.0, which will give you 12 points for that class. 4 credit hour biology class times each C is only 2.0, you only make 8 points. Okay. We made a D. D is actually 1.0. So your total points you earn from that class is only 3 points. So a grade point average, or GPA, is actually you add up the total points, total credits, different ways you can say it. Total points earned divided by not the number of classes, but divided by the total credit hours. Okay, divided by the total credit hours. How many credit hours do we take? 3 plus 3 plus 3 plus 4. That's actually 13 credit hours. How many points did I earn? That's 20 plus 12. I earned total of 32 points. So that will be 32 points divided by 13 credit hours. GPA always round to 2 decimal places. So that means I only have 2.46 GPA. Okay, that's how we find GPA, the weighted means. So to bring up the GPA right now, let's pretend we need to we want to make 3.0. Okay. To bring up my GPA, what should I do? Taking more classes or repeat classes will help me bring up my GPA. If you take more classes, that means you're taking more credit hours. So the denominator gets larger. Okay. So if the denominator gets too large, where the numerator doesn't, is not increased proportionally, okay, then your GPA can actually get lowered. So what you want to do is actually repeat some of the low grade classes, okay, to trying to bring up the GPA, because you want to have this points earned go higher. You want the numerator to go higher faster than the total credit hour in the bottom to go to go higher. All right. Now, one of the most important topic here is actually something called the variance and standard deviation. Okay, this is a little bit more advanced way of looking at your data. Something called dispersion. The word dispersion is actually measuring the spread of your data set. Okay, so to find the spread of data set, we will use something called range, variance, and standard deviation. The word range is very simple. It's simply the difference between the largest number and the smallest number. Okay, that gives you the spread. Which one do you think I would rather have? Somebody make two student, okay, well, in a class, would I rather have one student make 30 and everybody else make a 90? Or would I rather have a lot of students making 50s and a lot of students making 70s? Which one would I rather have? I actually rather have the top one because my spread is only 20 points. Because if I have a range of 60-point difference, that means there's something not right with the teaching. You know what I'm saying? How come some person got it and then, you know what I'm saying? Something is not right. The spread is too wide. So normally, grading wise, grades wise, we want students to make about the same grades. Okay. So your range is not so wide. Your entire spread is not so wide. So if everybody making high grades, we're doing good. If everybody's making low grades, that means we need to reteach some of the content, maybe something that students do not quite get. But when a lot of people, when some people make 90s and then everybody else make 30s, then there's a big gap. So then it becomes inconclusive of what the instructor should do, because I don't know what to do because I'll be wondering why so many people do well, but then why so many people do bad. All right. The word deviation means how far away or each data value is to the mean. Okay, that's the word deviation. The word variance and the standard deviation, both of them is referring to on average. How far is each data from the mean? Okay, I'll do some computation here in a minute so you understand what I'm saying. All right, the difference between variance and deviation is that the standard deviation is the square root of the variance. So I'm gonna try some. Man. Okay. All right, y'all can read through these different symbols. I will begin to use them. All right, find the range. So range is simply take the largest data value, subtract the smallest. That will give you a spread of the data. So I'm assuming 32 is the smallest. 64 is the largest. So 64 minus 32. My entire range of data is 32 points. Okay. Find the mean. So I'm actually gonna go ahead and find the mean by simply add them all up. Oh man, 28 was my smallest number in it. Yeah. 32 plus 64 plus 28 plus 34 plus 59 plus 35 plus 35 plus 41 plus 40 plus 40 plus 62. Just make sure we don't type in wrong. Okay. All right, the sum is 470. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Divided by 11, 42.73. So just for the convenience of my numbers, I'm gonna round to nearest whole number. Okay, let's just say 43 for right now. My range, sorry about that, 64 minus 28. My entire spread is 36 points. Okay. Now find the variance. Okay, this is the way how we do it. The first thing you do is list your data. These are your XI. $34, 59, 35, 35, 41, 40, 40, and 62. All right, these are all the data you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then what you do is the word deviation. How far away is each data value I have is to the mean. So what you do is you take xi, each data, minus your x bar. All right, so we know the simple mean or the average is 43. So 32 minus 43 gotta be negative 11. What that means is this number 32 is actually 11 places to the left of your mean. Okay, that's the way how that's what that actually representing. 64 minus 43, positive 21. So what's my, trying to find my calculator, I can do a little bit quicker. You can help me if you like. 28 minus 43. 34 minus 43. Negative 9. So all these negative number here means they are all located to the left side. On the number line, they are located on the left side of my mean, my average. 59 minus 43, 16. 35 minus 43, negative 8, negative 2. All right, negative 3, negative 3. All right, 62 minus 43. Positive 19. Okay, now, so what these number here means, these are the deviation. Okay, so to find variance, variance is actually referring to on average, collectively, what's the average distance to the mean. So I need to add them all up, right? Because average means add them all up, divided by so many I added. But the problem here is I cannot take a negative plus a positive. Okay, you actually throw my answer off. So to make these negative distance to the mean into a positive value, then we will actually square every one of them. Because if you square every one of them, they're all gonna become positive. Okay, so this gets robust. You know, if there's too many numbers, it gets robust. So if I take negative 11 squared, I get these 121. Okay, if I take 21 squared, 441. So now they all becomes positive. All right, 15 squared, is actually 225, 225, 81, 64, 64, 499. I don't know what 16 squared is. So I'm squaring every number, so they all become positive 256. All right, 19 squared. All right, 361. So now they go from negative distance, now assuming they're all gonna be positive distance by simply square them. Then I'm gonna add them all up. 121 plus 441 plus 225 plus 81 plus 256 plus 64 plus 64 plus 4 plus 18 plus 361. All right, I add them all up, which is actually 1635. All right, add them all up and divide by how many did I just added it? 11. So to find the variance, let me see what the symbol is. To find the simple variance, which is called S squared, is actually the sum of your xi minus x bar. Each individual data subtracts the mean, whole thing square, divided by so many data you have. So now I'm going to take the 1635 divided by 11, and that will give me my variance. Voila, 148.64. And it's okay, you can run a couple decimal places. I think on the homework, I may not mention it, but you can give yourself a couple decimal places. Now, that's my variance. So go back to this wording. The difference between variance and the standard deviation is that the standard deviation is a square root of the variance. Because remember earlier, we already squared a bunch of numbers. So now if I take a square root, standard deviation S will simply be the square root of your variance, which will be the square root of my 148.64 something. So 148.64. So give myself a couple decimal places, so that'll be about 12.19. It's going to be positive and negative here. So what that means is, on average, each one of these numbers I list at the beginning, on average, they are about 12 places above the mean, or 12 places to the right of the mean, or 12 places to the left of the mean. And that's what the standard deviation says. Standard deviation means on average, collectively, your average distance to the mean is going to be 12 places above and 12, and 12 places below. Okay, that's what the standard deviation is saying. So the smaller the standard deviation, the better. That means the data values are compact. Okay, then that's more of an accurate, it's a better data, basically. You can say it's better data. All right, so that will conclude this video on describing and analyzing data. All right, thank you for watching.